I'm Will Paxson. I'm an architect, a partner with Davis Brody Bond Architects here in New York City. And we were in the role of the executive architect or the architect of record for this project, working with Rafael Mineo, who was the design architect out of Madrid. We're sitting on the 10th floor of the northwest corner building. This is one of the shell floors. It's one of the floors that has not yet been fit up for research use, but it's ready to go. So it's sort of waiting for a determination of who's actually going to occupy this floor and what its initial research uses will be. Ultimately, our main interest is that the building really serves its intended purpose, and it really does act as a platform for interdisciplinary science and as a bridge. I mean, literally, you can use this building to move from the chemistry building into Pupin physics and then into Fairchild and Shapiro and over to engineering. So it's a connector. The challenge of the project then is to put a building where it wants to be, consistent really with the original master plan. But that means that this building has to span 126 feet across the gymnasium. And that was the technical challenge of the project. For us, it was a conceptual one of understanding the structural frame. This is a very big building to come down to the ground on a total of 8 columns, and to deal with lateral loads, wind loads, seismic loads, and the vibration criteria that we're working with. And ultimately, the building is an integrated structure where the diagonal bracing of the building is not just a truss with a conventional building on top of it. The building actually is a unitized structure that as a whole spans the gym and takes care of all the loads. And that's articulated in the facade. The constraints of the site really drove some of the aspects of the design of the project. We get the benefit, for instance, of the library because the building above is spanning across. And so we get a column-free space. So we get this sense of transparency from the main body of the campus, the plaza level, right through the building out to Broadway itself. And it's something which is spatially really nice. Similarly, north of the core, the large lecture hall, it's a column-free space. It needs to be as a lecture hall. We didn't have to pay a premium for that because the diagonal bracing and the trusses that are holding the building up gave us the ability to basically hang the structure that's on the north end of the building. McKinney and White were the architects and master planners of Columbia's original campus going back over 100 years ago. A brilliant master plan, one that really looked ahead. But at that period of time, turn of the century, chemists worked with chemists, biologists worked with biologists. We're really entering a new era now, or we have entered a new era, where a lot of advanced research is being done by collaborative teams. And this is probably the first building, at least on the main campus, that from the start, the planning was to be an interdisciplinary science building and to be a platform in which researchers coming from all different fields could share space, work together collaboratively. The other realization, I think, is the realization that the building's use will continue to change over time. And there will be people doing things here 10 years from now that we have no way of predicting. So to put in a robust mechanical infrastructure, we were interested, for instance, in a higher floor-to-floor height. And we wanted this building to be sufficiently rigid so that it would allow really state-of-the-art equipment. A lot of the equipment in the building, microscopes, et cetera, are very vibration sensitive. And if you don't produce a building with enough stiffness, it will compromise the use of those instruments. So one of the real benefits we got out of the higher floor-to-floor height was the ability to increase the depth of the structural framing. The castellated beam is a great solution because you get a deeper beam, deep enough to put these holes into the beam, which you can see. And then the mechanical system runs through those holes. And so we get, within the sandwich, we get the mechanical system and the structural system all integrated into one system instead of the traditional structure and then mechanical under that and a hung ceiling under that. It's a more efficient way to do the structural frame. The floor slabs are more vibration resistant than they would be otherwise, and we don't have as many columns. The labs are basically column-free spaces so that they're more flexible than they would be otherwise. To go on further, we were developing these really nice floor plans, But we found that a lot of the space was going to be occupied by basically desks and computers, and it was pushing out critical space for all sorts of scientific equipment. I think Raphael Mineo was thinking about this problem, we were discussing this problem, and came up with the idea of inserting a mezzanine. And that changed really the spatial dynamic of the building. It means that volumetrically the building is being utilized to a higher level than it would be otherwise. So now we've got faculty offices that we would have had anyway, but on top of those we have a whole network of workstations that are ideally set up to accommodate graduate students and postdocs and undergraduates who are going to be part of this research enterprise. The mezzanine means that the building is probably a couple of feet taller for each floor, and that additional 2 feet then went into the research space to accommodate taller equipment, to make the mechanical systems more flexible and more robust. So it's sort of a nice accident of all these things happening with really this one idea. Science is an incredibly creative and challenging field, and we wanted to make sure that the building wasn't just a building about equipment. It was a building for people to really work in and work collaboratively. That was always the essential part of the project. The research labs are very intense environments for the people working here. It wasn't that many years ago, maybe 40 years ago, when universities, corporations, when they thought in terms of research buildings, they thought in terms of windowless boxes. I'm really happy that it's not just a lab building from top to bottom, that it has a public life to it, so that it invites people in, it draws people in. And we were also cognizant that we really wanted the activities in the building to be visibly accessible to the campus. So particularly in the afternoon or in the evening, you can see all the activity, and you can see the fact that there are all sorts of different things happening on different floors. It's not a monoculture. It's a real mix of things. But we agreed, I think, as a team, design team with the university, the building wanted to have a public life to it. And the cafe is a critical part of that. It activates the sequence from Broadway up onto the campus. It really makes it a place to come in and to stop and to bump into people and to wait. And that was really important to Raphael Mineo, developing the form of that, the spatial form of it. I like particularly sort of the compression. You come in, the space is compressed as you come through the front doors of the building, and then you walk up a relatively shallow flight of stairs, and the space just sort of opens up and the view opens up, and suddenly you're above Broadway and you're looking out. The building was always talked about from day one, that this was a gateway to the campus in addition to being a research building, and it points towards Columbia's development to the north of Manhattanville, looking towards the future. This entrance to the campus will be used more and more and more heavily as the campus continues to develop over the next 20 years.